Okay, let's look at a typical microphone signal path. One of the first things that I usually put in my signal path is a high pass filter, and I grab the first one here that'll do 6 to 24 dB, and I drop it down because the first thing we want to do is we want to get rid of all the low frequency rumble and noise and p-pops and that kind of thing that's unusable. It's below the human voice anyway. The next thing I usually do is I put in a parametric equalizer. So I'll grab one of those, and I usually a 3-band is sufficient for most microphones. Now I do not use this equalizer to tune my sound system. I do that later downstream in the output section, and we'll talk about that in another video. But once that is tuned, then I come back and work on the specific microphone, a lavalier versus a handheld versus a podium microphone, etc., that each will sound a little different. Then the third thing I usually put in a microphone signal path, is a leveler. And that is giving us the ability to keep the loud person under control and the soft person better heard. Because what we're doing is we're squishing down the dynamic range without sounding squished, and which is an art form unto itself. So let's walk through, and I have just connected the high pass filter to the parametric EQ to the leveler, and we'll also connect that to our input block. Let's look at the individual pieces inside. Now the high pass filter, if we go in here, the default is a Linkwitz-Riley 12 dB per octave, and the cutoff frequency is 80 dB. And a Linkwitz-Riley, you'll notice that the frequency point, the cutoff frequency point, is actually 6 decibels down and from 0, and there's a nice smooth curve going into that slope. And if we change it to something, say a Butterworth 18, you'll notice that it's 3 decibels down at the crossover point. For a microphone, usually I'd like to have my vocal range, which most people, there's not much going on below 200 hertz in their voice, so I usually start at about 125. Here on my, I can either run it up this way or I can actually type it in. Go up here and start with a Butterworth 18, about 125, and that means at about 200 it's already starting to slope off, and we can adjust that a little more or a little less, so that with some rooms that have more low frequency rumble we can raise it up. Some rooms that have less low frequency rumble we can leave it lower and get a little more richness out of the bottom of the voice. Now let's look at the parametric EQ. And once again, I said that we would come back to this after we have tuned our sound system. But what we can do, an easy way to set a parametric EQ, is be careful of the level and be careful of the feedback. But generally speaking, what I do is I start by boosting it. And then I go up and down. So I've raised the level and I'm sweeping through different frequencies. And if we're doing this live, you'll be able to hear the different frequencies being amplified, and I'll go, ooh, that's actually the worst frequency right there. So let's come and bring a little of that away. So what I do is I boost it, I find what I don't like, and then I come back and I carve a little away. And with a parametric equalizer, we have 3 functions that we can work on. The center frequency, which is low to high in pitch. We have the amount of gain, which is the amount of boost or cut. And we also have the bandwidth, which is how we adjust how wide an area are we affecting. Now if this is more like a certain frequency that wants to feed back and it's a real narrow area, we can go real narrow and go deeper without affecting a whole lot of the signal. However, if we do a wide area, we want to use more, be more sparing in our movements, but we can do some overall general tone shaping. And so we can combine some of these together, do some overall general tone shaping, and then there's a real spot, let's say right at 125, there's a spot that's really kind of getting on our nerves, but in the lower middle, because we're in a concrete room, it's kind of boomy and muddy, so we can do a little curvature, something like that. And then maybe up here, there's this microphone has a little bit of a bite right at about 4K, and we can do a little notch there and maybe make it a little thinner. You know, whatever fits for that microphone and makes it sound best in your room. Okay, let's talk about the leveler. The purpose of the leveler is to take the loud person and bring them down in volume and allow the soft person to appear louder in volume. The process that we use is a cut-only process. Some processes use a boost and or cut. The problem we see with the boost is you're bringing up your noise floor when you boost, and you can send the system into feedback. We would rather just bring down the loud talker, and then the soft talker is taken care of by setting our proper gain structure, as we discussed in a previous video on adjusting our input gain here to where the average talker is reading between 0 and +6. The response time is looking at a window over which the peak averages over 1 second, 1000 milliseconds, equivalent of 1 second here, is at 0 dB. And if there is any peak, if our 1000 millisecond average is greater than 0 dB, we're going to apply a reduction in order to bring that average down to 0 dB. That's the default settings. Typically, if we've set our gain structure properly, we actually will want to bring this down to about -8 and change the time to about 2 seconds. And that's also really good for those of us in the South who talk a little slower and have a little more pauses in our meter. So that allows the leveler from not jumping and up and down, but because it's nice and slow, it can do a lot of reduction with very little noticing of the reduction, because the little peaks are going past the leveler and not being affected. So it sounds very natural. So anyway, the typical timing and response time and threshold that I start with is 2000 milliseconds and -8. What that means is the loud talker that their level is coming in at +10, it will bring them down because their 2 second average is probably hitting about 0 dB, and that will bring them down 6 to 8 dB. Then the average talker that is hitting about +6, their average 2 second average is going to be closer to about -4, -5, and so we're going to just barely be reducing their volume. And then the soft talker, their 2 second average between the peaks of their voice is going to be closer to -8, and therefore we're doing no reduction. So combined, the high pass filter gets rid of the low rumble and p-pops and all the unusable things below the human voice. The parametric equalizer allows us to tune this particular microphone to accommodate for any particular anomalies that this microphone has, where it has certain frequencies it does better than others. And the leveler allows us to equalize out the loud talker and the soft talker. Now, once we have this system in place for one microphone, we can highlight the entire signal path, and then we can do a Control-C for copy, just like any standard Windows command, and we can do a Control-V for the number that we need. Let's say, for example, with our CS we have 8 microphones, so I can Control-V 7 times. 1, 2, 3, 4, 5, 6, 7. You'll notice that you only see the 2. Well, actually all the rest are hidden behind here. So what we want to do is we want to drag a square around the high pass filters, and then we come up here to this neat little thing called pack left, which we can pack left, pack right, pack top, or pack bottom. In this case we're going to pack left, and when we click on it, it will take all of our high pass filters and pack them together and align up the left edges. So we can do the same thing with our parametrics. We drag a square around the parametrics, pack them, and we drag a square around the levelers and we pack them. And then we come back and we highlight the nodes and we connect up make our connections. And therefore we have our signal paths for our microphones.